Assalamualaikum warahmatullahi wabarakatuh. To my beloved lecturer, Dr. Zikri, my EMC lecturer and my teammates. Today I'm going to present my lab 3 for earth grounding system. And I'm going to present about procedure and also the introduction of the lab. So we will see from the explanation of the procedure for testing an earthing system using the 3-pole earth resistance measurement method. Firstly, the earth resistance measuring instrument is placed as close as possible to the existing earthing system under test. The distance between the instrument and the earth electrode should not exceed 10 meters to minimize measurement error. Next, 3 electrodes are identified. E is the earth, represents the electrode under test, H is the current auxiliary electrode, and S is the potential auxiliary electrode. E is X, H is for Z, and S is for Y that presents under the test for the electrodes. And then before making any connection for the test, the contact point of the earth electrode is cleaned to ensure accurate and stable readings that we measured. Then the distance between E, X, and H, Z is determined. In this lab, the earth electrode length is assumed to be between 1.8 to 2 meters. Therefore, the distance between EX and HZ is set to 10 times the length of the earth electrode. And this distance is measured using a measuring tape. After that, the measuring instrument is connected properly to the earth electrode EX and current stack HZ. The potential stack SY is then placed at 10% of the total distance between EX and HZ. Once positioned, the earth resistance value is measured and recorded in the table below. The potential, after the potential state that we measure and record, this measurement process is repeatedly by relocating the potential state SY to 20% to 70%. Estimating of the distance between EX and HZ. All resistance values are recorded systematically. After that, a second existing earthing system located near the first one is identified. This second earthing system is connected to the first using a suitable conductor, forming a multiple earthing system. The spacing between the two earthing rods is approximately equal to or twice the length of the earth of electrode. Then the same measurement steps are repeated for the multiple earthing system using the same percentage distances for the potential state. And then finally here we go for the introduction of the procedure. All measured data are recorded in a table neatly. A graph of measured resistance versus distance SH is plotted for both the single earthing system and the multiple earthing system. The results from both cases are then compared and conclusions are drawn based on the observed differences. That's all from me. That concludes the procedure for this lab. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Instrumen kat sini. Yang dia dekat bawah ni dia kan tersambung pada body. Boleh? Biasanya macam tu. Ini tiga. Dah mana ding? 3 meter. Tak ada. Aku tak aja yang geruk.
Ni dia injek 50 volt mati.
Bising.
Tekan ni kau nak rasa 50 volt ni lah.
101.9 kat.
4 meter.
Okey.
Tutup.
Ni 5 meter, 4 meter.
1.6.
Ya, bagi dia relax dulu. Okey, baru tekan.
Naik masa tak habis tadi.
Baby jangan pegang. Nanti ya, tengah-tengah test. Beritahu tengah test, beritahu kat abang jangan pegang
Jangan pegang air.
Okey, 218. Tak apa. Apa yang bacaan ada tu kita proceed.
218 ohm.
Okey, tekan test. Okey, dia ambil masa. Mungkin lebih kurang dalam 30 saat macam tu.
Assalamualaikum and good morning. So today our group will doing a lab 3 which is testing of earthing system. Earth resistance measurement using the 3-pole. My team member which is Muhammad Nakiuddin, Muhammad Afiz Shakir, Muhammad Haziq and me when I'm Farhadia. Okay, right. What is an earthing system? Okay, a safety system that connect electrical installation to the ground, and then because to prevent electric shock, protect equipment, and ensure stable operation. Okay, why test earth resistant? Okay, why? Because to verify that the grounding system meets safety standard, and also to make sure low resistance for effective fault current dispersion.
Okay, for the objective of this lab, first, perform a resistance measurement using the three-pole method. Second, to investigate the relationship between resistance and distance from the earth rod. And lastly, to compare resistance in single rod versus parallel rod configuration. The equipment we use for this lab is earth resistance tester, triple capable, earth rod, measuring tape, connecting cable and clamp, additional rods for parallel setup. That's all.
For equipment setup, that is Mega. Or EX is for earth rod under test. HZ is for current injection rod, and SY is for voltage measurement rod. Okay. For For experiment, we have two. That is single rod and parallel rod. Okay. For single rod, we place a HZ at 10 meter from EX. Then place XY at 3 meter, 4 meter, 5 meter, 6 meter, 7 meter from EX. Then we record resistance at each distance. Then repeat parallel rod experiment. Okay, we connect two additional rod in parallel with EX and ensure equal spacing. Then repeat same SY distance measurement, and then we compare the result with a single rod system.
After we do the experiments, we get when the single core for 3, 4, 5, 6 and 7 meter, we get the closer distance will give the lowest of ohm, and for the parallel we have a 3 copper. The first one is like here, there and here. Then when we connect the all the 3 of the rod, we get the resistance about 74, around 74 something. So from this we know that the more the rod, the ohms will be reduced. Okay, that's all. Why parallel rod reduce resistance? The first one is increase contact area with soil. The second one, multiple current path, reduce overall impedance. The third one, better fault current dispersion. And the last one, more rod will be a low resistance, ideal for high risk installation. For the result we get for a single rod, the higher resistance at close distance, and for the parallel rod, lower resistance across all device, stabilize